and we have tangent theta equals 3/4. And they're giving us another piece of information that sine theta is less than 0. So tangent theta is 3/4 and sine is less than 0. Okay. So I need a terminal side. I need the quadrant first. Tangent is positive, which means this or this. But it says sine is negative, which means this or this. I have established the quadrant. Very important, because otherwise I don't know the signs of the trig functions. I can determine everything quickly, but I need to establish the sign. So which quadrant is this? Which quadrant? Say it again.
Third.
That's it, of course, where both conditions are fulfilled. The third quadrant. Excellent. Good. So I have sine, which has to be negative. I have cosine, which has to be negative. I have tangent theta, which is given to us 3/4. I have cotangent theta. This is no good anymore. Sorry. I have cotangent theta, which is immediately the reverse of tangent. I have a secant theta, which has to be 1/cosine, so it has to be negative. And I have cosecant theta, which has to be 1/sine, so it has to be negative. So the first thing I do, I established all the signs so I don't forget. Okay. So now I have the following relationships, if you remember, right? We have sine squared alpha, alpha plus cosine squared alpha equals 1. And from here, we have two more that follow very quickly. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. I am given tangent. I'm not going to use this, and I'm not going to use this. Because I'm given tangent, I will plug it in here and determine secant. Once I have secant, I have cosine. Once I have cosine, I have sine. And so on and so forth. There is another option. I'm going to finish it, but there is another option. So there is a right triangle with an acute angle theta, whose tangent is 3/4. 3/4. The opposite over the adjacent. And I will be able to determine this. And we know the Pythagorean numbers. What number should this be?
5.
Exactly. Exactly. So, what is sine? 3/5. With the corresponding sign, because I took care of the signs first. What is cosine? 4/5. What is secant? 1/cosine. What is cosecant? 1/sine. What if I had continued on this path? Fine. 1 plus tangent squared, tangent, so 1 plus tangent squared is 9/16 equals secant squared. So this is 16 plus 9, which is 25/16 is secant squared alpha. When I take the square root, yes, the correct answer is plus or minus 5/4. I will have to cross it out because I can only use negative. I already have established the signs the moment I discovered the quadrant. In the third quadrant, sine, cosine are negative, tangent, cotangent are positive, and these follow because this is 1/this, and this is 1/this. Once I establish the signs, then I'm free to go. How do I establish the signs? They're all based on the quadrant. Any questions? Anyone? Any questions? Okay, so can we consider this done? Page 433. Can we consider this done? Are we okay with it? I wanted to go back to page 410. We may not need it anymore now, just for one question in there. Was it 410? No, it wasn't 410, sorry. It was, I'm flipping pages here. It was a different page. Yes, 420, sorry, we did this. Sorry about that. 420. So here was looking at working on any of this set. Did not use a calculator, find the exact value of each expression. Will anyone be interested to pick a problem here? Anyone? Is anyone with me?
You do 22.
Let's do 22. I am on page 5. And we chose 22. Where are you, 22? I see it. Sine 30 degrees times tangent 60 degrees. Perfect. Okay, so one option will be to change this immediately. And we have to remember this is the small angle. So sine is the nice number 1/2. This one, you don't have to memorize it unless you want to. I don't recommend it. This is sine 60 degrees over cosine 60 degrees. Sine 60 degrees is the big angle, so it's the ugly number if you want. And this is the big angle, but it's cosine, which is 1/2. So all we have to do is write 1/2 in front. I have the square root of 3 over 2 and flip 2 over 1. So the final answer is the square root of 3 over 2. So it's the product of two function values. Anyone has questions on this problem? Please, anything. Anything. If at any point in time the colors are not good, let me know and I'll switch to something else. Can we consider this done? Or we want to work on another? Yes or no?
We do 23.
Yes, let's do 23. And 23, and this is on page 420, and this is also on 420. Okay, where are you, 23? I see it. So it's secant pi over 4 plus 2 cosecant pi over 3. Perfect. Good pick. Good. So you don't have to ever worry about these two as long as you know that this is cosine 1 over cosine pi over 4. And this is 2 over sine pi over 3. So you never have to worry about secant or cosecant unless you want to. But you have to know the identity. Secant is 1 over cosine and cosecant is 1 over sine. So now I just fill them in. I know this one is the nicest of all. I know this is sine of the big one. So sine of the big one is the ugly number. I'm done. I have to flip. 2 over the square root of 2 plus 4 over the square root of 3. Ugly, I will write the square root of 6. I will multiply this by the square root of 3 and by the square root of 2. So 2 the square root of 3 plus 4 the square root of 2. Yes, you can rationalize if you want to. So the square root of 6, 2 the square root of 3 plus 4 the square root of 2 over 6. Yes, you can factor out the 2 and simplify. So the square root of 6, the square root of 3 plus 2 the square root of 2 divided by 3. I wouldn't do anything else. You could distribute and maybe further simplify if that works. This will be 3 the square root of 2, and this will be 4 the square root of 3. I'm not going to get any further, even if I do that. It was a nice pick. Good. I think we can move on to finish up on page 444. let's see what we have there. We did not get the chance to do anything here. But we talked about properties of odd and even. And I want to talk about the period of each function. So this is a very similar example with what we just did. You selected a similar one, 18 from homework. This is exactly the same. You find the point, you find the radius, and if you want to pick another one, we can. What I wanted to look at, another, and we'll come back to this, another angle, another trig function of a negative angle. So this is what I wanted to pick from. Using a calculator, we can show that, very easy, but I just wanted to pick another from here of a negative angle, a trig function of a negative angle. Would you like to pick, or I will? And I think I am on page 6. Anyone would like to pick? Is anyone with me? Anyone, please?
44.
Good. 44, you said? 44, we have cosecant of negative 30 degrees, and this is on page, was 444, right? 445. Good. Perfect pick. First of all, you can change this directly into 1 over sine of negative 30 degrees. And we know that sine is an odd function. So I have negative in front here, but it's positive at the top, so I can put it already in front of the fraction. I refuse to deal with the negative angle. I know that this is an odd function. Is negative sine 30. I put the negative in front. I know that sine 30 is the nicest number, 1/2, and I have to flip it. And that's done. Any questions on this? Do we need to select another, or is the idea clear? Do we know what we have to do? Yes? No? Please talk to me, please.
Professor, I'm confused how we got that -2.
So this number is 1/2. When I divide a fraction that is 1 over 1 by 1 over 2, I have to flip the denominator. So 1 over 1 times 2 over 1 will be 2.
Okay, thank you.
Thank you. Other questions here? Anyone? How do we feel about choosing another, or we move on?
Can you do number 51?
Yes, with pleasure. I don't see it. Oh, I see it now. So 51 on 445, and we have a tangent of negative pi. Perfect. First of all, tangent is an odd function. It has sine in it. If it has sine in it, it must be an odd function. No problem. Then I know that this is negative sine pi over cosine pi. I know that this is the point right here on the unit circle, right here. What are the coordinates of this point? Can anyone tell us quickly the coordinates of this point?
1, 0 or
Good.
-1, 0.
Excellent. But remember, this is cosine, and the second one is sine. So 0 over -1, 0. Very good. Okay, so let's, any questions? Always remember the so-called corners. They're not corners, but I like to call them corners. They're not corners, right? But these points are always the easiest. Because once you identify the point, the first coordinate or the x coordinate is always cosine. The second one is sine. Just put them in. Always go back to basics. It's the quickest than trying to find formulas and tables and so on and so forth. Always go back to basics. Okay, so last thing here, I wanted to go back to the previous page, but I need to explain, as we talked about the symmetry. So we can choose, as I said, another example from here if you'd like, but I would like to talk about the period of these functions. I said last time that they repeat in chunks. Okay, so here's the chunk. Imagine the graphing calculator from 0 to 2 pi. So in the 0 to 2 pi, we have a full, complete function for sine, cosine, secant, and cosecant. So the period of sine, cosine, secant, cosecant, the period is 2 pi. However, imagine the same graphing calculator viewing window, and imagine from 0 to pi. In here we have tangent and cotangent. What does this mean? Between 0 and pi we have all possible values for these functions, but here we have all possible values between 0 and pi for these functions. So all these four have this period, and these two have period pi. What does this mean? What am I really saying with this? Well, I'm saying this. Page 7. I'm saying that sine of 2 pi plus alpha is sine alpha. The same thing with cosine. Cosine 2 pi plus alpha is cosine alpha. Secant of 2 pi plus alpha is secant alpha. Cosecant 2 pi plus alpha is cosecant alpha. What about tangent? Tangent of pi plus alpha is tangent alpha. What about cotangent? Cotangent of pi plus alpha is tangent alpha. So 4 functions repeat themselves in chunks of 2 pi. Only 2 repeat themselves in chunks of pi, or blocks of pi. Good. So now let's choose. Use the fact that
Wait, I have a question.
yes, please. Anything.
When you're
Yes.
saying that they're repeating in chunks of 2 pi or pi, do you mean like the whole 3 or square root of 3 over 2 thing is repeating once you get past like 2 pi or something?
Yes. Very good. So let's clarify this. Very good question. Thank you so much. So when we graph f of x equals sine x, I have pi over 2, pi, 3 pi over 2, and 2 pi. Here's what happens. Sine of 0, I know is 0. Sine of pi over 2, I know is 1. Sine of pi, I know is 0. Sine of 3 pi over 2, I know it's -1. And sine of pi, 2 pi is 0. So here's the graph. This is a complete sine x. What happens next? This repeats here, and repeats again, and repeats to this side. So everything goes in the same copy, the same thing again, indefinitely. 1, 2, 3, 4. So this, and to the side, and to the negative side, and so on and so forth. So this is a complete graph of sine x from 0 to 2 pi. And it will repeat itself from 2 pi to 4 pi, from 4 pi to 6 pi, from -2 pi to 0, from -4 pi to -2 pi. Because the period is 2 pi. So when I'm here, for example, for this angle, at 2 pi, let's say 2 pi plus pi over 6, 12. At 11 pi over 6, I have the same value of sine as I had it here at pi over 6. Does it make sense now?
Yeah, thank you.
Perfect, thank you. So now I would like us to choose any of these so we can illustrate